Alright, hey guys, today we're going to talk about related rates, which is not so bad, but before we can approach any related rates problem, there are a couple things that you have to know. First thing you have to know are the rules, and I use DFDS to help me remember what those rules are. So the first thing is D, you want to draw out a model of the problem. F, which is formula, you want to find a formula that can relate the variables in the problem. D, again, differentiate. You want to differentiate that formula that you'd found with respect to time. And then S, substitute. You're going to substitute in the variables that you do have, and then you're going to solve for the unknown. All right, the second thing you want to recall is implicit differentiation, which is the bulk of solving a related rates problem. So say, for instance, I say, give me the derivative with respect to S of x to the fourth. What would you do? Right, so we would say 4x cubed, but times dx over ds. What if I said differentiate with respect to z, r to the fifth? What would you say? We would say 5r to the fourth times dr over dz. See the pattern? Okay, now what if I said let's differentiate y to the eighth with respect to t? Then we would have 8y to the seventh times dy dt. And this is the one that we're going to focus on to solve our related rates problem. All right, so let's jump into the problem. A balloon is rising vertically above a level straight road at a constant rate of 1 foot per second. Just when the balloon is 65 feet above the ground, a bicycle moving at a rate of 17 feet per second passes under it. How fast is the distance, s of t, between the bicycle and balloon increasing 3 seconds later? Okay, so at this point, let's recall our rules. df, ds. And remember, the first D is draw. So let's draw this picture. Now it says that a balloon is rising vertically above a level straight road. So when I think about a straight road, like in the street that I'm driving on, we drive horizontally, right? So that's going to look something like this. And then if the balloon is rising vertically, the balloon is going to be going up because that's vertical. Nice little balloon. All right. And then it says that the balloon is rising at a constant rate of 1 foot per second. So on this side, where the balloon is rising because it's going up from here, I'm going to label it 1 foot per second. And I'm going to call this side Y. I'm going to call this side X. All right, and it says just when the balloon is 65 feet above the ground. So let's say right here, we're at 65. A bicyclist comes along and he's passing at a rate of 17 feet per second under the balloon. So we have this guy on a bicycle, or this lady on a bicycle, and moving steadily along at 17 feet per second. So how fast is the distance between the bicycle and the balloon increasing 3 seconds later? So let's just get a thorough picture. So let's say after 1 second, the bicyclist is here. After 2 seconds, the bicyclist is here. After 3 seconds, the bicyclist is here, right? So we want to know the distance between the balloon and this bicyclist 3 seconds later. So, what picture do you see that we have created here? Looks something like a triangle, right? Yes, a triangle. So when you think back to your mathematical formulas, what formula can we pull that we use to find sides of a triangle or that relate something to a triangle? Yes, the Pythagorean theorem. So that's the formula that we're going to use. So we have drawn our picture. Now we have our formula. We're going to use the Pythagorean theorem. And let's recall that the Pythagorean theorem is x squared plus y squared is equal to s squared. And the reason I'm using x, y, and s is because in the problem it asked me to use s. So I know that this side, my hypotenuse, is going to have to be s. And then I use x and y for the sides of my triangle. So that's why I put x squared plus y squared. Typically you will see it a squared plus b squared equals c squared. It's the same thing. All right, so next thing we have to do according to our rules is we want to differentiate the formula that we have. So like we said earlier, we're going to differentiate this formula right here with respect to t. So let's go ahead and do that. So x squared with respect to t is going to be 2x dx dt, and then plus 2y dy dt, and that's going to equal 2s ds dt. All right, so that takes care of the first three rules pretty quickly too. So the last thing we want to do is substitute what we have into the equation and then solve for what we don't know. So right now, the only thing that we have a value for is the rate at which the balloon is changing, which is our dy dt. And then we have dx dt as well, because they told us that the bicyclist is moving at 3 feet per second. Now, let's see how we can find x and y and s. So it says that the balloon is initially at 65 feet. But the question is interested in the rate 3 seconds later. So if the balloon is moving vertically at 1 foot per second, that means that in 3 seconds, the balloon will now be at 68 feet. So we can say the y is equal to 65 plus 8. I'm sorry, plus 3. And that's going to give us 68. So our y is 68. Then our x variable says that the bicyclist is moving at a rate of 17 feet per second. So for x, we can just say 17 times 3, which is going to be 51. And you can think of it like this. In 1 second, he moved 17 feet. In 2 seconds, say he's here, this is the first second, you add another 17 feet to that, so then it'll be 34. And then at the 3rd second, this is where he is, and it's 51. Now we have our x and our y, so based on the Pythagorean theorem, we can solve for s, for our hypotenuse. And of course, we'll just use this formula right here to solve for s. So x squared plus y squared equals s squared. So if x is 51, we're going to say 51 squared plus y, which is 68. 68 squared is equal to s squared. Now, I'm just going to type this into my calculator. 51 squared is 2,601 plus 68 squared, which is 4,624, is equal to s squared. Then we're going to add those two numbers together. It's going to give us 7,725 is equal to s squared. And then, of course, to undo the squared, we take the square root. So the square root of 7,225 is 85. So s is equal to 85. And if you notice, we now have our x variable, we have a y variable, we have an s variable, we also have dx dt, and we have dy dt. So the only thing we have left unknown is ds dt, which is what we want to solve for. Now we can move into the final step, which is substitute. So we're going to take all these values that we have, we're going to substitute them into the equation, and then we're going to solve for the unknown. All right, so I went ahead and wrote down our variables here on a different page so we could go ahead and solve everything out nice and smoothly. Now, one thing I do like to do, because I noticed that there's a 2 here in front of each of my variables, I just go ahead and divide everything here by 2 and cancel those 2's out. So this cancels out. So now I'm just left with x dx dt plus y dy dt is equal to s ds dt. And I do that just to put a little less strain on the calculations I have to do mathematically. All right, so let's go ahead and make our substitutions. X is 51, so 51 times, and dx dt is 17 feet per second, plus y is 68, and we're going to multiply that by dy dt, which is 1, and that's going to equal s, which is 85 times ds dt, which we do not know yet. All right, so again, I'm just going to plug this into my calculator. So 51 times 17 plus 68 times 1, it's just 935. And that's going to be equal to 85 ds dt. And of course, to separate these two buddies here, we're just going to divide both sides by 85. So 935 divided by 85 is going to give me 11. So my final answer, the rate at which it's moving, the rate of the distance, between the bicyclist and the balloon, the rate that that's moving is 11 feet per second. All right, guys, that's it. Thanks so much for watching. Drop me a comment below if you would like to see a different type of math problem solved, and I hope this helped. Peace.